Hi everyone, my name is Di Wu. I'm an assistant professor in Embry-Riddle, Aeronautical University. So if you see the poster over there, there's a big eagle there. That's our logo. I'm very happy to be here. So some of my work is on the space sustainability side, which is quite different. It's a different direction from the de-extinction. Because like in the de-extinction, it's more like you have species going down, but in space, it's quite the opposite. It's like you have species number going up. And it's, it also possesses like a really high risk for the continuous development for the space industry. And because of the population of like, you can say an uncontrolled space object, which is like space debris or derelicts that comes from like dead satellite, all those things would actually possess a threat to like the future satellites that's orbiting around Earth. So that is the space sustainability side of the work. And also I do like things on the artificial intelligence that's involving on kind of like modeling, like how government performance and agency performance or large constellation like companies, their performance would impact on the space sustainability side. So that's like a brief introduction, yeah.
Awesome. So space sustainability is actually very new to me at the time when I talked to Professor Wu. Do you mind actually let us know a little bit about the industry? And what are the different disciplines within the industry, how they collaborate with each other, and then what is your research focus, and then what is the role of the research within the discipline and industry?
Yeah, definitely. So when we talk about space sustainability, it comes into, I would say, like multiple fold. The first fold is on the policy level. So for the policy level, you probably like involve like Congress or like lawmakers, logistics people. It's like designing missions, designing criteria for people to enter into space, and that makes a huge difference. And then on top of that, I would say it's like more on the operational level, which is more like doing observation, dealing with data, like you would collect all those like different informations about space, such as like the objects, like position data or spectrum data, like all those different kind of data, you will actually have like a huge collection of them, and people are trying to learn like how to best characterize the behavior of those like space objects. So that's kind of like on the operational level. And then I would also say there is another layer of satellite operator itself. It's more like you would have an active satellite within the space that's like crowded by different space objects as well. So not only space objects, but also other satellite operators asset. So you need to both like avoiding those like uncontrolled space objects, but also dealing with other operators, which is a big headache in the industry as well. So I would say that's kind of like the three layers that you will have. You can definitely go lower into the autonomy part about like a single satellite. So that's kind of like the industry itself. And then part of like a lot of like my research is definitely focusing on the policy level right now, because that's like the most like impact people can make regarding guarding the futures about space. Because like let's say what's the criteria of decommission that you must have for your satellite that's balancing both the economic gain for the industry and also guarding the space sustainability. So that is kind of like a trade-off question that we need to do a lot of like modeling on, and also to not only modeling our own performance, but also modeling all the other players in the industry, in the field. So that's like a very, very, very hard question. Yeah, so that's kind of like some of the things that I'm doing. Yeah.
Great, thank thank you for that. And then you mentioned a little bit about the pain point, and I wanted to also ask Max about it. What do you see as some of the challenges, pain points, when you, let's say, deploy some of the projects, and or you see in the process of bringing the animals back?
Well, certainly for us on the conservation side, the largest pain point is access to technology. AI has been amazing because I think it's helped democratize some of the technology so that, one of the unique things about conservation is it happens in every nation across the world, but every nation has very different capabilities, very different level of resources. So in some biodiversity hotspots, unfortunately, that's where we see the most economic depression. That's where we see the least access to tools. So trying to deploy cutting-edge technologies into these areas where they might not have the capacity is a real pain point. I think AI and the example of the tooth-billed pigeon is really incredible, that we're able to help develop a user interface that they can just download on their local computer, or even we've now created a mobile device so that researchers in Samoa can just go out with an iPhone and record animals and begin to detect tooth-billed pigeons on their landscape. So for us, it's been about trying to, how can, de-extinction's an amazing intersection of really cutting-edge technologies, right? Gene editing requires this immense lab, right? Genomic references, genomic sequences and creating reference genomes requires really amazing sequencing technologies. These are not things that you're going to find in most nations, especially biodiversity hotspots. But AI is a tool that can quickly be deployed, can actually be shared, quite easily. And so for me, I think I see AI as a bridge to help overcome a lot of these sort of technical differences between the different nations.
Awesome. And then for Dr. Wu, how
Yeah.
do you see that? What are some good use cases that you for AI as application or solution for some of the pain points that you've been seeing in the industry?
So I want to kind of like say like I actually learned a lot from like what you're describing about like using generative AI as an embedding layer for the behaviors. So that's also kind of like happening in space. So we are dealing with large amount of data, and the pinpoint that I'm seeing right now, quite contrary from like the sound denoising part or like the sound generation part, it's like we have too much data and too little insights. So I think it's because like when we're doing all those like space exploration, we're always collecting everything. And we're saying, okay, in the future we'll do some like analysis. And like the instrument that you were showing like earlier about like doing the onboard selection of the data and the information, I think that's something that needs to happen in a space industry at the instrument level. And also, I think like even for that, there is another layer of challenge, is kind of like on the explainability and responsible use of AI for space industry. So I was very fortunate to talk with like a Lockheed CEO the other day. He was basically telling us he could have the autopilot helicopter, like the system there. But when they're doing the demo for that autopilot helicopter, they have to make sure every line of the code can be explained to the administrator. So for the AI part, obviously you can embed it into some of the like estimation part or evaluation part, like to generate a value function. But then you still need to have a explainability side. How does that AI help to generate your final decision? So I think that's actually a really challenging side about like interpretability of like how to apply all those like models into space problem.
Awesome. And then with that, we see many of the use cases that we can use AI to solve the problems within the industry. What could be some low-hanging fruits? What could be some high-hanging fruits And then with all those use cases, how we prioritize them? What are some of your criteria? Let's start with Matt.
I think the data analysis is the low-hanging fruit for conservation. You talk about having too much data. In conservation, we often talk about not having enough. We don't have enough. We haven't found ways to scale data collection. Technologies are really helping us with that. Also, our data probably isn't that great because our methodologies are still, 100 years old, which in the AI world is ancient history, right? Globally, we lack data. Locally, we have way too much data in specific areas, and we don't know how to analyze it. So AI is becoming a very powerful tool. There's amazing companies out there, such as Map of Life, or sorry, it's an NGO, but Map of Life and others that are finding ways to harvest data from a bunch of resources, distill that, and display that in a way that's really usable for a lot of people. So I think that's the low-hanging fruit. AI is going to help tell us more about the natural world than we know, or tell us we were wrong about a lot of things we thought we knew. I think, I work at a moonshot company. We're trying to create technologies that most people don't think we'll ever be able to achieve. And so in that sort of moonshot vein, I think AI for nature will eventually become this amazing array of instruments like what I showed, not just in Yellowstone, but across the world, collecting everything from video to audio to environmental DNA and other forms of data, and analyzing that real time, and almost act as a canary in a coal mine for a lot of ecosystems, and begin to make predictions about the direction the stability of an ecosystem is heading. Find key indicators within an ecosystem, key species that might be thriving or diminishing, and use that as a way to tell us here before, right? Conservation is this horribly reactive science. It needs to become more proactive. So before this ecosystem is collapsing and will be impossible to stitch back together, tell us we need to intervene. Not just tell us to intervene, but probably even tell us how to intervene, using modeling to be able to say, here's 1,000 solutions we've come up with, and these are the ones with the highest chance of success. So for me, I really continue to try to spread the word across the conservation community, which is, by its very definition, highly conservative and probably not on the leading edge of the technological fields, that we need to begin to be developing these tools, because we currently live in a world where the Paulson Institute just did this amazing study. We live in a world where we're seeing enormous biodiversity decline every year. In order to just stop, not reverse that biodiversity decline, we need to spend about $850 billion a year. Every year, globally, we're only spending about $150 billion a year on conservation. We have a $700 billion shortfall. That's not just a gap of funding, that's a chasm, right? That's impossible to overcome. We cannot 10x our spending. We can barely double our spending. So what I see is using tools like AI to help reduce the cost of conservation, help improve the efficiency of conservation, and then become a much more proactive science. So if we can kind of create those efficiencies, we can use technologies to tell us where we should be most focused and prioritize our resources and act early. It's much easier to put out a fire when it's small and local. When your whole house is on fire, it's much harder to save the house. So I think AI is driving us there quickly. I think AI's ability to exponentially advance other sciences and technologies is going to make a world of difference for conservation.
Awesome. And how about you, Professor Wu?
Yeah,
How do you think about it?
Yeah, definitely. So I think the low-hanging fruit comes from the collaborative development in science and technology from the general foundational AI. So the question I ask myself all the time is we have all those foundation models that's able to do generative things. Are there things that can be generated from this basically scenario building to enable the exploration of policy level settings for space sustainability? Because this is, in my understanding, is the proactive side of space sustainability. Because we are dealing with a timeline of 10 years in the future, 20 years in the future. It's really hard to imagine what the scenarios could be. And I believe using the generative AI, we can generate the different scenario that can be evaluated further. It's just like, I think like the first keynote speaker was showing this, like generate hypothesis, testing hypothesis, and going back to evaluate and adjust your policy, right? So I think that's kind of like a part of like this whole automation like toolkit can help us. That can be really like efficient right now. But obviously like it goes to the explainability side. It's like, how do we explain it to the policymaker, the whole process, and then how do we make them trust the process? Yeah, so that's kind of like a little bit of challenge there within the low-hanging fruit about like space sustainability and the use of AI in that. But I think like on top of that difficulty, there's another layer which is the more of the math and the physics-oriented part about AI usage in space, because like space is essentially a physical system, and it's a quite chaotic system. So it means like a small change in your initial point would result in a huge difference in the future. So this very sensitive part to data currently is not too friendly to artificial intelligence. So I think that's kind of like maybe that's a, I couldn't really tell if that's a medium level or really high level like difficulty. But I think that's kind of like a challenge there as well. Like another thing I think like that can be done right now with some of the analysis is actually on the data side. As you have said, like you also have the problem of like too little data in general, but too much data in specific point. So that's also kind of similar to us, because like we have too much data in general, but too little structured data or usable structured data for like specific point. So how do I, like, I mean, NASA, they've been trying really hard. They've been doing really good. They're like converting all those like heritage data into more like a modern data set that like more people can get access to. But still, like, because of the sensitivity about this industry, it's still a little bit lagging behind to make like every data set as structured as possible. Even on the side of space objects, there are like, let's say like, not let's say, there's actually like 1 million space objects around, like space debris orbiting around Earth that can be devastating to satellite right now. But like all those data are generated, not generated, all those data describing the motion about those like space debris, they're given in the like non-intuitive two-line element plus no uncertainty side of the data description. So that data information is like we're pushing the industry to give more information about their data, but it's in the process. And I think like this is where like artificial intelligence and generative AI can help with the process.
Great. And then I think both of you have talking about a lot on the data. I wanted to dive into it a little bit, and then we'll go to the model side. So then for the data itself, with AI, it's definitely solving some of the problem, but then will you create some of the concerns? What are some new concerns that you've been seeing with AI?
So I would say yes. So like when I think about like generative AI, like one problem that I'm seeing in a lot of like my work is the asynchronized use of time. So like for one object, you will probably have like data at time step 1, 5, 10. And for another one, you probably have like data at 1, 2, 6, 7, 11. So you would have like a really hard time to calibrate your model so that it can be a general model for all the objects because of the raw data part, the asynchronized use of the raw data part. So the traditional way of doing it is to kind of like propagate and your raw data into this like evenly separated time steps. And in that process, you are introducing kind of like artificial error into the process. And then, as I said, it's like a very sensitive, chaotic system. When you introduce this little error from your model, you're deviating from the reality. And obviously, we can try to improve our model to make it closer to reality. It's sometimes really hard because it's like, I would say it's probably because the dynamics environment is highly chaotic. But that actually would introduce maybe another good opportunity of like using generative AI to generate different data set and then to do all this like collaborations all the time, together all the time. So I basically think it's like a hard time of like both introducing like artificial error, but also it can also be a really good opportunity for like a new models to exist.
Yeah, I think that the biggest issues we're seeing on the conservation front are a lot of concerns around some of the dual use of the AI and the tools and the data collection, right? In the conservation space, a lot of species are threatened with extinction because they are being overexploited for some resource. You know, in the case of, say, white rhinos that are being poached in southern Africa, if we're creating really great data sets, open source data sets, we're creating predictive tools, we're learning how to predict movements, we're figuring out all these things to help manage the species, there's somebody on the other end that will use that to help exploit the species. And so there have been a lot of concerns, especially when we start talking about critically endangered species, about not making these tools open source, not making the data readily available because of that concern, which is really unfortunate because I still think the availability and the democratization of those tools is net positive, even if there is a dual use concern. But that's where we see the most resistance in the tool right now.
Do you see on top of that, right? Do you see some of the researchers who are using the data with AI? Do they have like some trust issues, or they think that this is something that, hey, I really wanted to try and really wanted to experiment on it? And how do you see that dynamic? And how do you make understand it and then help people to adopt AI?
People that are attracted to the field of conservation science are, by definition, by their very nature, skeptical humans of other humans, right? These are people that have been attracted to animals and wildlife, and they don't really love people. So we see a lot of trust issues. There is, even coming from a for-profit background from Colossal, even with our nonprofit foundation, when we approach people, they often say, well, how are you going to use the data? You're going to find a way to profit from it. Which my answer is often, it's like getting blood from a stone. Good luck. We're not going to make much money off the conservation world. But the other side of it is we should be finding ways to drive economic value into the preservation of nature. Right now, the way that we derive economic value from nature is the exploitation, the destruction, the harvesting of a resource. We're trying to find ways to change the economic equation for nature where you can make money, things like emerging carbon and biodiversity credit markets, things like that are going to help. But yes, they're almost always very skeptical of even us when we're trying to produce data, let alone sharing that data readily. One of the ways I think we get over it is we find really forward-leaning partners and we pilot these programs and we show immense success. Unfortunately, that is very much of a crawl, walk, run model before we can really make the changes we see in the world. But that's what we're doing now. We're really lucky to have 40 partners that are helping us sort of model these efforts across the world right now.
And then I also wanted to look a little bit into the future, right? So AI now is flying, like a lot of people are talking about it nowadays. We definitely wanted to get to know it, learn about it, and then apply on it, apply on AI. So, but then in the future, do you see people will use more and more of it? Or do you think that they will, especially in the field of conservation, right? Will you feel like they will be more concerned about some of the things? What is the sentiment going on over there? And then what would be some good applications of AI in the near future? And what will be, and especially in like maybe 3 to 5 years?
I think what's a really great trend in the conservation space right now, which is predominantly funded by philanthropy, is the large funders like our foundation and others are pushing partners into using these tools. They're funding projects specifically focused on more emerging technologies, interesting projects. I think most people recognize that for the last 100 years, at least here in North America, we've been practicing conservation a certain way that continues to fall further behind. So they're pushing people to use the tools. So I think, it's like any other trend. I think this trend's here to stay, but I think like any other trend, AI is becoming a thing where even people who don't really understand it are saying, "Are you using it?" Which is really great because that's forcing the hand of a lot of very conventional conservation organizations. So I think in the future it'll, especially on the data side, I think it'll be a really heavily adopted tool, and we'll continue to focus on that. I think there will be companies like Colossal, Biosciences, and the Colossal Foundation that use AI in really other interesting ways to power tools, other tools. So, without AI, we could not have de-extinction because we need that predictive ability in order to know where in a genome we should be editing.
How about you, Professor Wu?
Yeah, definitely. So in short, definitely yes. Because I think it's goes to the nature of space, like space industry. You operate in this resources limited environment. Either it is for a single satellite operation, or you are operating in this limited orbital resources in domain. So I think for things like the limited resources for a single satellite, obviously, if you have something that's providing the intelligence that's needed to deal with different or all kind of different scenario that may come that you cannot really predict in advance, that's going to be a really huge thing. And that's also kind of like one of the onboard AI part of the research in my lab is doing. And on the other side about more close to the sustainability or limited use of orbital environment, orbital resources, I think that's where a better observation and a better understanding of the observation data, which needs to happen. And how do we make that happen? I think AI is one way to go. But definitely beside optical improvement of those things, our understanding over data and the productivity of using those data to derive our understanding of the space environment needs to go up. And that's also something the industry is trying to do, or reaching out to different companies, trying to do collaborations on those, building those foundation model for space environment. Yeah, so I would say definitely yes.
Awesome. Before we conclude the session, any questions from the audience for Professor Wu and Matt? Yes, please.
So if you look into the UN definition about space sustainability, it's the continued use of space for the future generation, right? And that actually needs to put into some more content there. And right now, different people have different definition. In my definition, is actually the ratio of active satellite within the space versus the total number of objects in space. So in my understanding, it's like if we can make the best use about space, that's the best scenario. If like all of our satellite does not get threatened by all those other moving objects, that's the best scenario. So this goes to like both like providing economic gains and also develop technology. So that's kind of like my understanding there.
And also, I think Matt has mentioned something relates to economy before. So it's not only about space sustainability. Overall, sustainability have like three important pillars, right? One is environmental. Even what Professor Wu have been talking about is actually part of the environment, right? There's also the social and the people side of the house as the second pillar. And then the third pillar is actually what Matt has been talking about is the economy. So everything need to need an economy for there to support. So then it's actually a sustainable process cycle, and then everyone will be able to engage and connect with. And that's a little bit about the explanation on sustainability.
What that gentleman was saying, can you quantify what you're talking about when you're talking about space? Like, what's the difference from from our atmosphere outward? Like, because to me, space is vast.
Gotcha. Yeah. So there is like some consensus on how to define like the different layers about space. Right now, we're kind of like using 200 kilometers above the Earth's surface is the start place about space. So you can say 200 to 2000 is a LEO, low Earth orbit, and 2000 above until you reach GEO, which is 384,400 kilometer. Yeah, so that's medium or like Earth orbit, and then there you have the GEO orbit. So I would say yes, there is a kind of like a agreed upon criteria about like a different regions about space. To give you guys like a better understanding of the height, International Space Station is 760 kilometers above like Earth, so it's like in Leo region, and also Starlink, yeah, Starlink is like I think like 800 kilometers, 800 to 1,000 kilometers. So you see like they're sharing the space. It's like rhinos sharing the space with elephants, and you do need some like a behavior like modeling over there. Yeah, that's what I'm saying.
Thank you. We have time for one more question.
Hi, thank you guys for being here. This is super interesting. I want to ask you guys about how do you think about margin of error? Because both of you work in industries where I'm sure there's a lot of ethical and safety considerations with gene editing and with space objects. So how do you think about the risks?
Yeah, I mean, in the de-extinction front, in the gene editing side, it's obviously an enormous risk. We need to utilize AI to help make predictions about the intended outcomes of an edit. However, you cannot be sure what your edit is doing until you create an organism. So we do a lot of in vitro testing, a lot of quality control. We also use things like organoids, if you've seen, in order to help show that the edits that we're making have the intended effect. But then the risk is further complicated by if you can create a dire wolf, which we did, right? And you wanted to put it back on the landscape, how does it impact the ecosystem? So again, we're leaning on models to help predict the impacts that happen there. None of what we do, at least on the side of de-extinction and conservation, happens in a silo as well. We're a heavily regulated, unfortunately messy regulation environment, place where we have to deal with a lot of folks in order to not just use animals in the field of de-extinction, but actually any impact that happens to the greater environment. So enormous risk in every layer of what we're doing, heavily mitigated by some great science and great quality control, and then further there's a lot of oversight from especially the governmental side.
Yeah, so I would say like for the risk, like there is a shifting mindset toward like what the risk means, and I think like right now under the economic content, the risk is like for companies to increase their cost, but it turns out if you have like a better operating environment, you actually have a lower cost. So this is where we see a lot of like industry like companies like Kuiper or like Starlink. They're actually very active in like collaborating with academia to both define and also providing ways to do the sustainable development for space. So when companies understand the benefit about sustainability, that's actually really powerful, and I actually like to see that happening. But also, yeah, I think like I wouldn't really call it a risk. It's more like opportunity to all those companies. They can find this chance to improve their technology, to increase like autonomy, to increase their like artificial intelligence level, integration level with space. So I think that's actually a good thing. Yeah.
With that, we'll conclude the session on AI and planet. Thank you so much for our speakers, and also thank you so much for the questions.
Thank you, guys.
And then next, we will have the session about AI and arts. And this is one of the most interesting session throughout the day. You will see a lot